Value of a polynomial. What do we mean by value of a polynomial? For understanding the value of a polynomial, let me show you an example. Whenever I plot a polynomial on a Cartesian plane, I will get a curve or a straight line. Let us take a straight line graph which is obtained from a linear polynomial, and let the linear polynomial be 3x plus 4. Let this linear polynomial be 3x plus 4. So, different values of x, I will get different values of y, which we have learnt in linear equation, and I will get a straight line graph. If I have to find the value of this polynomial, here fx is equal to 3x plus 4. Suppose I have to find the value of fx at x equal to 3. This is my 1, 2, 3, and this is 4, 8, 12. These are the different values. If I have to find the value of the polynomial at x equal to 3, then I will find out that for x equal to 3, what will be the corresponding value of y. So, here the value of y will be 13, but every time we can't be drawing a graph to find the value of the polynomial. Then what would you do? Taking the same example, fx is equal to 3x plus 4. Value of polynomial at x equal to 3. Value of fx at x equal to 3 is written as f of 3. Now, how do I find the value? I find the value by inputting 3 in place of x. So, in place of x, if I substitute 3, I will get the value of the polynomial at x equal to 3. So, this clearly shows that at x equal to 3, the value of the polynomial will be 13. Let us understand it very clearly now. I have already given you an example. Value of a polynomial px at x equal to a is given by pa. That is, simply in place of x, I will substitute the value a in the given polynomial. Example, if px is equal to x square plus 2x plus 6, which is a quadratic polynomial, the value of the polynomial at x equal to 2, how will I get it? Simply by substituting the numerical 2 in place of x everywhere. So, it becomes 2 square plus 2 into 2 plus 6, which finally gives you 14 as the value of the polynomial. Now, coming to zeros of a polynomial. What are zeros of a polynomial? We know what are values of a polynomial. How do we get the value? Just by substituting the value of x. Now, zeros of a polynomial. Zeros of polynomial are nothing but those values of x which will make the polynomial equal to 0. What value of x do I choose so that I get fx equal to 0? Zeros of a polynomial px is a number such that p of a, that particular value of x, will make the polynomial equal to 0. 0 may be 0 of a polynomial. Every linear polynomial has one and only one 0. 0 of a polynomial is also called the root of the polynomial. A non-zero constant polynomial has no 0. I would like to explain each point clearly. 0 may be a 0 of the polynomial. Now, let us consider a polynomial fx equal to, the same example I will take, 3x plus 4, which is a linear polynomial. It is a linear polynomial. Now, I have to find out that value of x which will make fx equal to 0. So, if I take x equal to minus, if I take x equal to minus 4 upon 3 and substitute it in place of x, f of minus 4 upon 3 is equal to 3 into minus 4 upon 3 plus 4, whereby I will get minus 4 plus 4 equal to 0. So, every time I have to think of that value of x which will make the polynomial 0, but thinking about that value is not easy. So, what is the method? The method is simply putting fx equal to 0. I know there is some particular value of x which has made polynomial fx equal to 0, and in order to find that out, I have to frame this equation fx equal to 0. So, in place of fx in the second line, I will write 3x plus 4 equal to 0 and x equal to minus 4 upon 3. This is similar to solving a linear equation. After solving a linear equation, I have got the value of x as minus 4 upon 3. This is the 0 of the polynomial and is also known as the root of the polynomial. It is also known as the root of the polynomial. Again, there is a connection between 0 and the degree. If it is a linear polynomial, it will only give you one solution or one root. If it is a quadratic polynomial and the highest power is 2, so eventually you will land up with a solution x square is equal to a number 4. If x square is equal to 4, for example, if I have taken x square equal to 4, then the value of x will be either plus 2 or minus 2. So, what do we see that for a quadratic polynomial, I will have 2 zeros or 2 roots. If it is linear, it will have 1. If it is quadratic, it will have 2. Again, we come to a conclusion that the 0 of a polynomial is always equal to its degree. It cannot be less than its degree. It is always equal to its degree. So, 0 of a polynomial, which is also called the root of a polynomial, is also called the root of the polynomial. A non-zero constant polynomial has no 0. Let us see. If I have a constant polynomial fx is equal to 4, obviously 4 cannot be equated to 0. So, a constant polynomial which is a non-zero polynomial will never have a 0. Graphically speaking, a linear polynomial or a non-zero constant polynomial will always be a straight line parallel to x axis. And if the line is parallel to x axis, for all values of x, I will get the same value of y. So, there will be no particular value of x which I can select as the root of the polynomial. Every real number is a 0 of the 0 polynomial that I have shown you, that is, it will be a line parallel to y axis. So, I will have any real number is a 0 of a 0 polynomial. A polynomial can have more than one 0. A polynomial can have more than one zero in case of a quadratic or a cubic polynomial. The maximum number of zeros in a polynomial is always equal to its degree. I told you the connection between degree and zeros of the polynomial. If it is a linear polynomial where the degree is 1, the 0 is 1, it cannot exceed beyond 1. If the degree of the polynomial is 2, I can have maximum 2 values of x. Let's start with the most important part of polynomials, the remainder theorem. The remainder theorem is derived from the division algorithm, and what does it state and where do we use it? We use it to find the remainder when one polynomial is divided by the other. So, if Px is any polynomial of degree 1 or greater than 1, that if it is a linear polynomial or a higher degree polynomial divided by another polynomial, then what will be the remainder? If Px is divided by a linear polynomial x minus a is a linear polynomial because the degree of x is 1, then the remainder we can simply be obtained without performing the long division by substituting the value of x as a in the given polynomial which we are dividing. So, it is based on division algorithm that dividend is equal to divisor into quotient plus remainder. Here the divisor is x minus a. We have to find the quotient and the dividend is Px. Now, let us look at the steps, the very simple step to find the remainder. What is the remainder? If x raised to by just solving this example, will come to know that how to find the remainder very easily by applying the remainder theorem. If this is the given polynomial x raised to the power 4 plus x cube minus 2x square plus x plus 1. Yes, this is a polynomial of degree 4, and if it is divided by linear polynomial x minus 1, then how do we find the remainder? The first step is we'll first find the root of the linear polynomial. Now, to find the root or the 0 of the linear polynomial, I'll put x minus 1 equal to 0. Now, putting x minus 1 equal to 0, I'll get the root of the polynomial x as x equal to 1. Now, I'll simply substitute this value of x equal to 1 in the given polynomial which has to be divided. Substituting the value of x equal to 1 in Px, we get 1 plus 1 minus 2 plus 1 plus 1. 1 raised to the power 4 will be 1, 1 raised to the power 3 is 1. So, it is 1 plus 1 minus 2 plus 1 plus 1, which will finally give me the answer as 2. So, this 2 is nothing but the remainder that I will get by dividing a polynomial of a higher degree, that is degree 4, by a linear polynomial. Let us start with factor theorem, which is another important theorem telling us about the factor of a polynomial. But before that, let us recall what is a factor. Factor of a number, as we have studied earlier, is a number which divides the given number exactly. So, when I am talking about factor of a polynomial, it is another polynomial which divides the given polynomial exactly, and we get a remainder 0. So, in the factor theorem, if Qx is any polynomial of degree 1 or higher degree, then and a be any real number, then a linear polynomial, another linear polynomial x minus a will be called a factor of Qx if the root of the linear polynomial with which I am dividing, that is x minus a, the root of x minus a, as we know, the root of x minus a will be a. So, for this value of x, substituting this value of x in Qx, if I get the value of the polynomial as 0, then only x minus a will be said to be a factor of Qx. Conversely also, if for any value of a, any real number, if I get the polynomial to be 0, that means if a is a 0 of the polynomial, then x minus a will be a factor of Qx. Let us study this with the help of an example. What is the remainder if the given polynomial, the degree of the polynomial is 4, is divided by minus 1? If it is divided by a minus 1 is a polynomial of degree 1 which is dividing a polynomial of degree 4. So, if a minus 1 divides, then as we discussed, what will happen? The root of the polynomial a minus 1, the root of the polynomial a minus 1, let us see what it will be. The root of the polynomial a minus 1 will be 1. To find the 0 of a minus 1, we need to equate it to 0. As I said, 0 is nothing but the root of the polynomial with which we are dividing. We are dividing by a minus 1. So, first we need to find out the root of a minus 1, which will be equal to 1. Now, we substitute the value of 1 in the given, a as 1 in the given polynomial. If I put a is equal to 1, then P1 will become 2. If P1 becomes 2, that means a minus 1 is not a factor because I am getting a remainder 2. So, as I am getting a remainder 2, it is proved that a minus 1 is not a factor of this polynomial.